Okay, let's look at one more example by using the energy and work principle equation. So if you look at the diagram, you're having a pulley system. When you look at pulley system, you know that you need to recall the relative motion between two bodies, A and B. If you pull A, something will happen to B. If you B drop, something will happen to A. Right? So if you look at the diagram, this is a pulley system and it always deal with the datum. So your datum is at this level. The distance, positive distance from datum referring to uh, object B is going down positive, SB positive. Same with A, measure from datum going down positive, SA positive go down. So without looking at the statement here, we'll look at this statement later. Look at the diagram. If you're given such a system, can you guess the motion of the two objects? If this one, B is 100 kilogram, A is 10 kilogram, you put your hand here and you let go. What happened to A? What happened to B? B going to move down, right? More heavier, right? So B move down, A will move up. Okay, before you solve any question, just look at it and then think logically. So B, if you let go, B will move down. When B move down, A move up. So what happened? How you link your SA and SB in the pulley question? You're using the rope to link A and B. Yeah? You use the rope, the length of the rope, to solve the relationship between SA and SB. Just recall, it's always the same. The principle always the same, or the strategy solving question always the same. Look at pulley system, identify where is the positive direction for SB and SA. Then link SA and SB with the rope, or with the chain, or with the something that relate to A and B. Okay, right. Then you come back to the statement. Most of the time it will give you the mass information. So mass is so and so. Even in the diagram already given already. It asks you to determine the distance B travels when it released from rest. You're given the velocity before the incident to the point where its speed become 2 meters per second. You look at the question, you look at the statement here. What do you have? You have mass, you have the velocity. Velocity before start and at the interest of point 2 meters per second. Basically, you have V1, you have V2, you have mass. So basically, when you have mass, you have velocity, what you can calculate? Kinetic energy, half mv squared. And then you have the weight over here. You have the mass over here under gravity. So again, force and displacement go same way, you get positive work. Force, displacement go opposite direction, you get negative work. Force and displacement 90 degree, you have no work. Okay. Once you have all this information, the rest is just reconstructing the free body diagram and put in the correct equation. Transfer the information into free body diagram. Oops. Okay. Change from this one into free body diagram. Same steps like the previous one when we talked about pulley. So your free body diagram, you just copy the system and then you change all the cable into tension of cable. All right, this is tension of cable. R1, R2 doesn't move, it's just your constraint there. Mass moving down, weight moving down, weight moving down. So your A is 10, 10 times 9.81, 98.1. Or you can just put WA, this one WB. WB, 9.81 times 100. You get 981 Newton. Okay, so this is a free body diagram that we're talking about. Then we start to put in the equation of work and energy. Okay, free body diagram. So by looking at free body diagram, you know that how many force you involve. This one doesn't move. This one doesn't move, right? These two things doesn't move. So when there's doesn't move, no motion, no displacement. So force with zero displacement, no work. So this one no work, but tension have some distance moving. So this one have work. This one weight going down have displacement, so have work. This one also have work. Write the principle of work and energy equation. Kinetic energy T1 plus work done equal kinetic energy at point 2. Substitute all the equation. I expand. In this case, before start, you have two body, which is the A and B. So you have kinetic energy of A at point before it start. So I mark as TA1. Same with B, right? Kinetic energy before start. Since we have two body, then I have kinetic energy for B before start or at initial time. Work done equal to point number 2 or after the event. So again, I have two body. So I have kinetic energy for A body, kinetic energy for B body. Okay, so this format is applied to pulley system. Okay, this is 2. Right, you should able to do when I increase the diagram into 3 body. So maybe, so basically the concept is this diagram we have 2 bodies, so you have 2 kinetic energy, 2 kinetic energy. The work done here is based on free body diagram. Okay, deal with the force and displacement. Okay, so if you understand this equation, you're almost done. Huh? So the rest is just expansion of the equation. You know kinetic energy equation, half mv squared. So this one A, this one B, velocity A, velocity B, plus the displacement of this one, work, plus the work. So how many work you have? Work A, work B, and the kinetics energy of A and B at point number 2. Okay. Okay. Now in this case, you see there's a T there, the tension over here, right? Why I do not have work on this tension? You refer to this diagram. This T is T. Does this rope moving? This rope was mounted to the wall also. So T, R1, R2 doesn't do work. Huh? This one doesn't do work. Okay, so that's why it explains why in your work equation here, although there's a tension cable here, there's a tension in the cable, but the tension here doesn't do work because it's mounted to the wall. It doesn't move at all. Okay. So the first thing, it moved from rest, right? A, it moved from rest when it released from rest. So 0, 0, both begin with rest. So no velocity when it start, no velocity when it start. So no kinetic energy before we start. Okay. So this is the equation between the G and S. This is the work done by the gravitational force, right? This one is here. So WA, what is W? mg. So M plus G, you get 98.1. B, W equal to mg. W times S, you get work. Both positive. So this one equal this one. This one, you copy, substitute the mass of A, mass of B. Mass of A, mass of B. Inside this equation, unknown SA, unknown SB, unknown V2A, you have 3 unknown there. So you need another equation. When you see pulley system, always link SA and SB with the length of the cable. After that, you substitute inside here, you solve the remaining question. Okay, stop me if you're not able to understand what is this equation about. Okay, let's move on. So we try to link A and B with the length of cable. This one you expert already. What is the total length of the cable in the system? SA plus SB 1, 2, 3, 4. You have 4 SB. Yeah? So SB, 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 SB plus SA. SB, 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 SB plus SA. So this is the total length of the cable. So you have length of the cable equal to 4SB plus SA. And you know the purpose we do this one. After this, we convert this one into acceleration or even in velocity by differentiation over time. Length doesn't change over time, so this one becomes 0. 4, this one becomes VB, this one becomes VA because you differentiate this one with the time. And you integrate one more time, you get acceleration. So 0 equal to acceleration 4 acceleration B plus acceleration A. Okay, this one we already covered in the previous chapter 2 or even chapter 1 when we talk about pulley system. Okay, you get this one. When you differentiate one time, you get velocity. So you rearrange. You can either pull VA to the left hand side or you can pull VB to the left hand side. Doesn't matter. As long as you get the relationship between VB and VA, because you want to find the speed and you want to find the distance, right? Right. These are the two unknown that we need to solve because in the previous equation, we are missing this one, VA. Huh? So this equation, minus 4VB equal to VA. You know the velocity of B. You know the velocity of B at that particular point. So you substitute here 4 times, when VB equal to 2, you have minus 8. So when your velocity of B reach 2 meters per second, the VA is minus 8 meters per second. So your VA equal to minus 8 meters per second. Check negative sign, correct or not? You let go of B, A move up, Y negative. What is your SA? Positive direction. Positive direction, SA go down. Why you get negative? Because your A move up. when you let go of B, A will move up. So that's why you get negative sign here. If you get positive sign, it doesn't logic. Means something wrong in your calculation. Okay, when you let go of B, if you get positive value for VA, means something wrong in your either your datum or your reference system here. Okay, so you have this equation about work, right? So substitute, this one is just now, the equation just now. So substitute VA inside here. You basically solve this side. What is SA and SB? You see this one? Right, change of SA and SB. You have these two equations here. Right? So your SB equal to this one, going down. You're solving simultaneous equation, yeah? When you substitute this one in, you only left out SA and SB. But here is another equation. You have the L for SB SA. So you try to link between SA and SB. Okay. You solve SB. Okay, any question? SB positive going down. You get a positive value going down because datum positive go down. Any question? There's a, yeah, go ahead.
What will happen to the L?
What happened to the L?
After you uh, use the equation to solve the main equation?
Yeah. So the L actually is a fixed value. You have this equation, right? And this is a fixed value. Length doesn't change. You can even substitute any value over here. When you substitute inside here, right? Does it give you the length? Does it give you length? Okay, so here the length here is not given, but the length doesn't change. You can just substitute, assume L equal to something. L equal to 1, L equal to 2, L equal to 3. Once you substitute inside here, right, you have the SA and SB relationship. So you can substitute the length between SB and SA, right? So let's say you assume L is 1. Okay, L is 1. Or you can, if you don't want, you can just carry along the L in your calculation. Meaning in your calculation there is a L inside there. Right? There's a L inside there. Okay, so this one, help me to check. Sometimes I have a typo error where sometimes I miss out something in my answer that I give it to you. All right, so here you have L equal to 4SB plus SA. In the question, it doesn't give you the length. right? It doesn't give you the length, but you have VA, right? So you have VA. You know that the ratio between VA and VA and VB, right? Correct? You know the ratio between VA and VB, right? What is a VA and a VB? Can you see the ratio? You move A 1 unit, what happened to VB? What happened to B position? You move 1 unit, VB going to move 4 unit, correct? You have the ratio here, right? From here, you know the ratio. You move A 1 unit, SB going to move 4 unit. Even from here. Let's say this is length is a constant. So the portion between SA and SB, total is 5 portion. So, but you know the ratio between 1 and 4. Okay, you know the ratio between the SA and SB. All right. So the ratio is SA equal to 4SB. So you solve SB equal to this one. Do I explain the logic behind? Just now who asked the question?
Me, sir.
Yeah. Do you see the logic?
Yes, sir.
Yeah. So here you see the ratio of 4. Here also, actually, you can see is a ratio of 4. Okay. Even here, this one, total length equal to 4 portion of SB. So basically, you can do the ratio over here. Okay, we move to a new section. We talk about, we have done with the work. Now we deal with power. Power and efficiency. Why power and efficiency, they link together? Because efficiency always measure what is going out to the what is your input. Output divided by input, you get efficiency. All right. So in power, when you take amount of work multiply by the time, you get power. Okay. What is power definition? Power is amount of work within the time frame, or in the mathematics model, power equal to du over dt. Power equal to du over dt. This is a differential equation. Change, small changes of work divided by time, and you know that you can move dt to the left hand side, right? P dt du, you can do integration. The change of work equal to P multiplied by time. But anyway, this is the fundamental for power. Power equal to du over dt. We already explained how to find work. This basically is just a derivation scale where you derive versus time. Right? We start to expand the equation a little bit. Work equal to force time displacement, and it's a dot products. Force dot products of your displacement, it become a scalar products. Right? I already included appendix B about what is vector, what is scalar products, right? So modify this one, work become force dot dr. You move your force outside a little bit, it become force dr dt. dr dt is your velocity. dr over dt, you get velocity. So force multiplied by velocity, you get power. Okay? Force multiplied by displacement, you get work. Force multiplied by velocity of itself, you get power. Force multiplied by velocity. See the unit. Force is in unit. Force is in Newton. Velocity is in meter per second. Newton meter per second, you get power. Or we put in the unit of watt, as you learned in your introduction to electronics. Power is measured in watt, W-A-T-T, watt. So this slide tells you how you get power calculation. Power equal to force multiplied by velocity. Okay, in the unit of watt. So this second session, there's a conversion between watt and Newton meter per second. This is Newton, force is Newton, velocity is meter per second, Newton per second. You know that Newton meter is your work. Newton meter is a work. Force, Newton, displacement meter, force, displacement, you get work. What is the unit of work? Joule. So joule per second. You have 3 conversion unit here. 1 watt equal to 1 joule per second equal to 1 Newton meter over second when you talk about power. Okay, so I think it's clear, very clear information here. Let's look at efficiency. We have done power. Power equal to force multiplied by velocity. Then back to your understanding in efficiency. Efficiency is what your ratio between your output and input. So efficiency symbol is this one, phi. All right, or efficiency symbol. Efficiency equal to output divided by input. You take power output divided by power input. Okay. Maximum efficiency is 100%, but this is a ratio. You know that ratio, you always get one number. Maximum ratio or fraction number. If your output equal to input, if your output equal to input, let's say you input 10, output 10, what do you get? You get 1. 1 efficiency, it means 100% efficiency. If your input equal to your output, you get efficiency 100%, or in the ratio form, you get 1.0 efficiency. Maximum value for efficiency is 1. Minimum value for efficiency is 0, because if you input 10, there's no output, you get 0. Okay. And if you put input 0, output, you have number, something wrong. You have no input, no output. Okay, if you have no input, 0 below. If you have output in your system, something wrong. You are another Einstein in this era where you don't need to put something in, but you get something out. You are in the quantum physics dimension already. Okay. The rest you can read here. So power, also similar things. You can also write as energy output equal to energy input. Just now, before this, we learned about one kind of energy here, which is kinetic energy. And in your physics, you learn that energy have a loss of form. Conservation of energy states that you cannot create, you cannot destroy an energy, but you can change form from one form of energy to another form. you learn about kinetic energy, potential energy, chemical energy, mechanical energy, and so on. So here you see energy output, energy input. Just to summarize what you learned so far, you only see kinetic energy. So kinetic energy input with the ratio of kinetic output, you get efficiency. If the question asks you to focus on kinetic energy only, then you can use this ratio, right? Let's look at one example and then we call it a day. You have one worker that is working hard pushing a box with a force of 150 Newton. Fine. And the force is working in an angle, but this angle gives you a trigonometry relationship, 3, 4, and 5. In your tutorial question, you will see maybe this one very small, but there is a trigonometry equation over here. 3, 4, and 5, you have triangular trigonometry here. 3, 4, and 5, your force acting at a certain angle at the hypotenuse triangular, your hypotenuse of your triangular, moving this way. So you are given a mass. In the statement, a move push a 50 kilogram crane. So you know that unit SI for mass is kilogram. Again, we have seen one example just now where the unit is in megagram. When you do calculation, remember to use unit SI for your mass. With a force of 150 Newton, determine the power supplied by the man to the box here when time equal to 4 seconds. Coefficient of friction is 0.2. Initially, the crane is at rest. Okay. Now, up to this stage, what information you have? You have mass, you have velocity before start, you have mv, add a little bit, half mv square, you get kinetic energy, you have energy there. And just now, it asks you to find about power. Recall back 5 minutes ago when we learned about power, force displacement, you get work. What about power? Power is force and the velocity of the object. Force times velocity, you get power. Okay, they must be in the same direction. Yeah? Force and velocity direction must be the same. Force is a vector. Velocity is a vector. Vector have magnitude and direction. Both must be in the same. Only power can generate it. Let's move on. So we have free body diagram, and later we use equation of motion. So first we determine the forces, the velocity of 50 kilonewton developed by the man. So I draw a free body diagram. First things in free body diagram is always your gravitational acceleration, which is your weight. Weight equal to mg, right? So for all free body diagram that you draw, first thing you draw besides the object itself, the first thing you draw is the weight. W equal to mg. And as we mentioned just now, this object have a contact on the surface. Have a contact on the surface. So when you have contact, you have a normal direction. Sorry, let me silence my phone. Okay, so when you have a object with the surface, you have a normal force. So later you'll see normal force over here. All right. So this normal force is automatic when there's a contact between the object and the surface, you have a normal force. This normal force is going to help you to find friction force. If the man pushed the object to the right, the friction always opposite the direction of the motion. Okay, the object was pushed in this direction, so the friction force is going this direction. Yeah? The box is pulling to the right, the friction always fighting the motion, so going to the left. Friction equal to mu n. Within, you take this one, multiply by the normal force. You get friction force. Okay, plus the force by the man, and again the force is given in the trigonometry relationship 3, 4, and 5. All right, so acceleration is in this direction. Okay, acceleration is in this direction. I just combine with the kinetic diagram here. So free body diagram plus the kinetic diagram. You can move it here. F equal to ma. Any question on the free body diagram? Steven, you okay? Steven, are you okay?
Yes, sir.
All right. Okay. So let's move on. The free body diagram already explained how you get it. Next, you solve equation of motion. F equal to ma. In y direction, going up is positive. You change all the forces, not change lah, but you focus on the y direction forces. This one you can split into two forces here and here. Okay, these forces, resultant force, you can change into this direction and this direction. So you're focusing on y, you have this one, you have this one, and one component going down, which is negative. And also F equal to ma in x direction. Going to the right is positive. There's a trick. There's a trick to identify the direction. You follow the direction of your object. The object is moving to the right with acceleration of a to the right. That's why I decide that to the right is positive. I always follow F equal to ma direction. I always follow my acceleration or object acceleration direction. Yeah. So I think you're familiar the next steps once you have F equal to ma by using free body diagram and kinematic diagram. So this one, y n minus, going down, sine theta here, minus w equal to may. Do you move in y? Does the object move in y? So there's no acceleration in y. So may a0, so here 0. N equal to 150. This is 150. And you know that this is a right angle triangular. What is sine? This is the angle you want to find, right? Okay, this is the angle you want to find. What is sine? Sine is opposite and hypotenuse. This is your I, or this is your angle. Opposite divided by hypotenuse, 3, 5. W equal to mg. This equation, only one unknown. You solve for the n. N equal to something. What is the purpose of finding n? N is to help you to find friction force. Friction force equal to mu times the n. This one. Okay. So back to x direction. F equal to ma. X direction. How to determine the x direction? Always follow the acceleration direction or acceleration of the object direction, which is going to the right. So you know that this one you can split into this one and going down. So to the x is this one, is cos. If you look at this diagram, what is cos? Cos is side divided by hypotenuse. Friction, I already mentioned, friction by using n value, max. Okay, max. Substituting the value, 150 cos minus 0.2 n value that you find just now equal to 50 ax. So this equation, you only left out your acceleration in x direction. Right, press your calculator, you find your a acceleration in x direction, which is 0.078 meter per second square. I pull the value, just put beside my diagram. I have my n, I have my a, I have my friction, I have my weight at my normal force, I have my acceleration. The question asks us to find the power, right? At 4 seconds. Again, remind yourself what is power. Force, displacement, you get work. But to find power is force and velocity. Force and velocity. So to find power, you need to find velocity of this object. So velocity, you use the Newton equation. V equal to V naught plus ACT, because acceleration is constant. So you can use this equation. V equal to V naught plus ACT. You have your AC, where you find just now, this one. Time given by the question. Question asks you 4 seconds. Acceleration 4 seconds. What is your initial velocity? Crane start from rest, so 0. Velocity of this box at 4 seconds, substituting the value, you get 0.312 meter per second to the right. You have the V. You want to find the power. Again, what is power? Force multiplied by velocity. Force, velocity, you get power. How many force you have here? Right. Okay. So you have P force divided by V. If you know that the V is moving in x direction, right? This V is in x direction. So all the force that parallel to the velocity, then you get power. Fx multiplied by V. Okay. So force. We take this one, the force. The power supply. The question asks you, power supply by the man. So we focus on this force rather than other force. Okay, look carefully. The question asks you about power supplied by the man, which is only the red arrow. If the question asks you, what is the total power in the system? Combine the man and the box. You need to find all the equivalent force in the system. This question asks you power supplied by man. So in your free body diagram, what is the force supplied by man? With this one. So you focus on this one. Force in x direction is cos theta times V. You have the force 150. What is your cos? Side divided by hypotenuse. 4 divided by 5. Multiplied by the velocity you find just now. You get your power equal to 37.4 watt. This is the power supplied by the man. Supplied by the man to move the parcel at the speed of 0.312 meter per second. This is the power supplied by the man. Again, Sorry, up to here, any question? Any question want to ask me?
So far, no, sir.
No, okay, so again, be careful when you read the question. Sometimes the question can be tricky. It can be, what is the total power in the system? In the system means you look at the free body diagram, you look at the velocity, total up all the forces, means these forces combined with these forces, friction force, multiply by the velocity of the system, then you get power, right? But this one you focus on the power supplied by man. Okay, I think we stop here. Let me end the recording.